So anyway, so all right, while this goes up, let's hopefully it starts. Not seeing on the screen here. All right, good. So yeah, so we're live. All right, guys. So a hypothesis then is an assumption, opinion, or predicted reason as to why the problem you are given occurred. All right. So now for this one, and because it's your first plan and design, I just give you some examples of it. The problem that I find with students is that they would have a good idea for the hypothesis, but the structure of the sentence is not what it should be. And because of that, I give you a little prompt here to show you what would pass as a good hypothesis, right, for this problem. And you're seeing here that you get 1 mark for this, which you get 1 mark for choosing it. So I don't want no students to give me back this lab and write all 4 here. I just want you to write 1. Okay, just write 1, the one that you choose. Or if you feel like coming up with your own, that's also accepted. But these are just 4 examples, and you get marked for choosing 1. If I say all 4, all right, I won't be happy, and I might just give you back a lab to fix it. All right. Anyway, so we'll choose one of the following. That's the point here. All right, let's look at them individually, and I'll set them up so that these 4 sentences actually saying the same thing or similar thing. All right. So the first one says a mixture of sodium chloride, ammonium chloride, and sand can be separated using filtration, sublimation, filtration, and crystallization. Now, I'm going to stop at this one because I'm going to underline these because these are labs that you did before. Except the crystallization one, we haven't done crystallization, but I could show you what that looks like, and you get your own idea of it. All right. So with crystallization is something, is a technique that I think every chemistry student or anybody serious about chemistry should know. All right. As a matter of fact, there's a nice little video here on crystallization that I'm going to let you look at. All right. So see when and how you do crystallization. And all right. All right. Just a second. I'm going to actually share this with you guys. All right. All right. So it should be on screen 3. Everybody seeing the screen?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right. All right, let's go back here. I want to share something. All right. Crystallization. What is crystallization? All right, guys. So stick up in there. All right. I hope you're seeing this information. Very crucial here. All right. Giving you a clue towards what you should do in this lab. Salt is obtained by the evaporation of seawater. Seawater. This is interesting though, because this is just one way you could get salt. From the sea. But all right. So salt is obtained by the evaporation of seawater. However, this salt is impure and has small crystals. Again, you're seeing where a technique like this would be useful in real life. All right. Any questions so far, guys? You understanding the video?
Yes, sir.
All right, let's go ahead. All right. All right, so then you see a definition for crystallization. Process of formation of large crystals in pure state from their solutions. All right, so this will come in handy for this lab. All right, now let's proceed. All right, guys. So that's it. All right, guys. How you found the video, guys?
Interesting and easy to understand.
Okay, lovely. All right, and that's the idea here. Most individual topics in chemistry are easy to understand, but it's when you have to put them together in a single situation that might be challenging. So crystallization by itself is straightforward, all right? So guys, as you probably can see here, all you do here is just get the solution and then you let it evaporate slowly. All right, leaving behind crystals. All right, of course, the string in this video, if you can, could ask a question why a string was used here, but usually things like these, this is just to increase the surface area so the crystals can form on it. All right, but yeah, all right, guys. So this gives you an idea here, because if we go back to the lab, one of the things that make up the white powder on the teacher's table is actually sodium chloride, which is the same thing that these these characters were using. All right, so let's go back to that. And guys, anybody have any questions though?
Okay.
Okay, so hopefully, all right, so everybody understand the video and we can use the knowledge here. So nobody is a stranger to crystallization. No, all right, just a big word, but a very simple concept. All right, no, sublimation, filtration, as we say, you saw that the lab that we did. We did filtration here as well as one of the as lab number 4. So you want to separate the mixture, and then let me just underline this. The white powder is a mixture of these 3. All right, white powder. And the problem is that a white powder, using a white powdery substance, you know, it could be anything because many, white powder could be anything really. Could even be drugs, and so in
Like
this case,
cocaine, sir.
you're getting specific there, Janari. But you know about cocaine, man. All right, careful enough. All right, so yeah, the mixture of these 3 is the white powder. Because you know what 3 things are in the white powder, that will guide you into which or how we're going to use these techniques. The problem is that which order would we use these techniques? And so we know that these 3 techniques are used. But then each of these techniques we're going to use, you're going to have to tell me which one will be separated by each of these. Because if 3 things make up the powder, then we have to use 3 means of separation to separate them. So question is, what would you do first? And what would you do last? What would come in between? So the hypothesis then is, as assumption, you're assuming that this mixture can be separated using these 3 techniques. So anybody's gonna choose number 1? As you say, choose one of the following. Anybody look like they would choose number 1?
Yes, sir.
All right. Who is that
Yes,
now?
sir.
All right. All right. Let me just write your name. Who said they want to choose number 1 here?
Onika did, sir.
Okay. Onika?
Yes, sir.
Oh, no, Onika. There. Let me just
And Leandra.
Onika and Leandra. All right. All right. Let me just
Sir, add me, Lamar.
all right. Leandra and Lamar. Okay. All right, Lamar. All right, so 3 persons. All right. Nobody have to rush this one. So that's cool. All right. So that's cool. So the first one is understood. Second one, mixture of sodium chloride, ammonium chloride, and sand can be separated using sublimation, filtration, distillation, and crystallization. So this one, distillation, would be used in this one. All right. Anybody care to do this one? It's distillation. I think I showed you what distillation was. It's usually, all right. Distillation is it's the process where you boil the water. So in the crystallization video where you saw him putting it in like a pot or something, if a distillation no, you wouldn't put it in a pot, you would put it in a special flask where it would boil more evenly, and then the water would separate, leaving behind a very saturated mixture in the flask. So it's the same thing as boiling and evaporating. But personally, I believe if you use distillation, you might just get a purer product, right, than bypassing it. So you're going to end up doing the same thing for number 2 than as what you did for number 1. Only thing now is that you're going to be more, you're going to get a more refined product in the end. So anybody thinking of doing the second one here? And
Wind.
all right, Brittany. All right, okay, Brittany. Well done.
Me too, sir.
Who's me? That's with me.
Deborah.
Deborah. Oh, so you finish hang out already, man?
Me too, sir.
Tara, nothing.
No, me go now.
Man, you make this one go down, man, and probably, rain, it might just get some rain today. All right. All right, so Brittany, Deborah, and Tarashi. So, all right, this is good. And don't be afraid to work together on these labs, guys. I mean, if you're doing the same one, why not work together, share information, meet up, you know, if you want to use Zoom and so, just do that. Don't be afraid. It's your subject, your class, you want to pass. Do all that it takes. All right, so we have 6 persons confirmed for the first 2. So we have the next 3, the next 2 now to get persons involved here. All right, methods of sublimation, filtration, and crystallization can be used to separate a mixture of sodium chloride, ammonium chloride, and sun. All right, so it's just the same thing, but it's reworded. So 3 and 1 is like saying the same thing, but just reworded. Anybody's gonna take this one?
Yes, sir. Casey.
All right, Casey. All right, good Casey. All right. And of course. All right, and 3 and 4 is close as well. Actually, saying the same thing. All right. So I have heard now from Janari and Michaela. What's happening? You're
I
unusually
don't know yet, sir. I'm just looking. Sir.
just looking. Okay. You're unusually silent though, Janari. Hope everything is okay. All right. Michaela? All right. Well, Michaela kind of chickening out here. All right. So let's move on then, because while you're ponder this one, I mean, it's no matter. Really, we end up doing the same thing, regardless of which one you choose. But it's just that I give you these 4. I don't want everybody to have the same thing. If 2 or 3 persons have the same thing, that's okay, but not the whole class have one thing. So want some variation, want some variety. All right. So it must look like, say, all right, when everybody bright and come up with a similar thing, not the same thing, but a similar thing. Just a few words, different expression, etc. That's why I have 4 examples here. All right.
Sir,
Yes, go ahead.
if
Tara.
I go back through them and want to change the
Yeah.
hypothesis, can I?
You can.
Okay.
Yeah. All right. Anyway, so can we move on, guys? Securing a mark here just by choosing one and working with it.
Yes, sir.
All right. Good. All right. The aim now, guys. For 2 marks, you get the aim. The aim now, we're looking for 2 things. The aim must link to the hypothesis. So, and then secondly, it must be something that when the moderator or I read it, it is testable. It is something that, we can say, that can do in the lab. So those 2 things we look for. Must relate to the hypothesis, must look like it can carry out.
If you said to separate a mixture of sodium chloride, ammonium chloride, and sun, like that.
Yeah, you'll get, that would be, you get 2 marks for that if you write it like that. You understand what I'm saying?
Yes, sir.
So so that's it. Reword whatever you're using. So in the case of Onika, Leandra, and Lamar's selection, you could say that your aim would be to separate a mixture. And this to separate a mixture. It could have been let's see what's happening here. Yeah. All right, to separate a mixture. I could be lazy here. I could just even I'll just copy this. I'll just take over that. Oops. Yeah, but all right. All right. So yeah. All right. Let's just fix that. Or it could be like that. Yeah. Oh yeah. And we take out that. See that? Just converted it into an aim. But you see that?
Sir,
No,
it's
sir.
off, sir.
What's
So
that?
we're not in.
Screen off.
Off.
Just chip out, sir.
Oh, I know I go on. My computer go on bad, man. All right. You still not seeing it?
Sir, and see it now.
Seeing it now.
I'm seeing it now.
Okay, good. All right, so let's just showing you guys how, and let's choose a decent color here. All right, so then that's what you'll have here. Separate a mixture of sodium chloride, ammonium chloride, and sand using sublimation. Let's take out the can here. All right, so this would be the AM that and use here, Onika and Leandro and Lamar. All right, so any questions here? We'll go there so we can continue then.
Yes, sir. Can continue.
Yes, sir. Continue.
All right then. All right, good. So with that said, we have this aim. Now the next thing. So that means that for persons who are doing the second one now, we could actually do the same thing, except that you're going to add crystallization in it. So
Yes, sir. That's what I wrote. I just add the crystallization in it.
all right, very good. All right, methods of sublimation, filtration, and then it's going to be the same thing for cases. So not much work to do there. In fact, let me just add the Latin word for everybody, which is et al. So means everybody. All right. So then we go to this then. We can move on then. That's 2 marks though. So so far you get 3 marks. And the thing with plan and design labs, it's to me it's easier to get the marks. For it. It's just that persons just have a mental block to it because they have to do they think they have to do a lot of work, which if you're on your own with it, it can be. But I'm guiding you here and showing you here, you see that it's easy to pick up marks. 3 marks already. Interesting. Because you see, for these labs, you're not focusing on getting results, or it's like you don't have to say, well, if you see the right color, or if you did measure it the right way. This one is just about understanding it and writing what you think, which would be already in your brain. All right, so all right, let's go. Separating, sorry, the materials used for the separating is something that you would have to add here. The trick here for the materials for 3 marks, we are looking for, well, if they are appropriate, if they relate to what the aim is saying, and of course, yeah, those are 2 things, the main things we look for really. Must relate to the aim in the sense that if you're going to separate, then using these techniques, you need to show me then, all right, what would you use for the sublimation? That should be listed here. What you use for the filtration, that also should be listed, and also for crystallization. All right, so there's an example I wanted to show you of this though. Let's go to the, and then what I'll say to you here is this, that, well, the apparatus and materials and reagents make up the 3 marks, by the way. So the reagents is the chemical you're going to use. So like for example, if you're going to use water to mix anything, then that would be a reagent. All right. So right out the bat, we know that we're going to use water at some point. So we're just going to put that under reagents. So don't put water under apparatus or materials, guys. Those are physical things that you use to to manipulate the reagents. All right. Anyway, so water is there. Everything else would be a material for the most part. All right. So the question is now, what would you use? What would your setup be for sublimation? All right. What would your setup be for sublimation? All right. You can do one of two things. You can go back to the lab that we did for sublimation, which would be, I think, your second lab. And you can write those materials there. All right. Whatever you use for that lab, you could use it for this one. All right. Yeah. You could also have a, funny enough, this you could actually do this at home though, This could be done at home. Thinking about it. If you were to carry this out. And remember, guys, that for any plan and design lab that you write, you have the option of carrying it out to get some extra marks, right? So there's a number of ways we could set up for sublimation. I think the diagram that I showed you and the second lab that you have, right, is that you could use that. But let me show you this image that would help you to understand here. I'm wondering if all right, let's show it just the same. Oh, this one is all right. Let me show you this. I think I'm going to need some space here. This is the diagram. All right, I'm going to show you in the diagram. As a matter of fact, no, we're going to make another page. New slide. We're going to drop it here. All right, guys. So this would be like a setup for your sublimation. Hope everybody's seeing this one. All right. So let's make this smaller so we can have space here. All right. So all of the stuff you're going to use for your materials, guys, it should resemble this. So let's see here, you have your Bunsen burner. This is source of heat. Your tripod stand should be in the apparatus and materials. And then we've seen another reagent that we need to make mention of here. In fact, the reagent is actually the white powder mixture. So we start to see where the reagents are different from the materials and the apparatus. All right. So where guys, you could add that to the list as well. China dish, and then that's 3. And you have your inverted funnel and your cotton plug. So that's 4 and 5. All right. So see there, guys, there are 5 things that you can write down for your materials. Any questions so far, guys?
No.
All right. So let's just write this as a diagram. It's just materials used for sublimation. All right. So no, that's one. All right. Now let's look at the other technique, which is the filtration, is it? Let's go back to it. It's filtration. All right. So let's see now. What would our setup be for the filtration? Anybody can guess what we're going to use for filtration?
A filter paper.
Obviously, yeah. You like that. That's very, very sharp there. And filter paper would go there as well. All right. Anything else?
You like the material, I'm sure.
Yeah, that's what I'm talking about.
A beaker.
Okay, Brittany.
A funnel.
Inverted funnel, could I say
Funnel.
inverted funnel?
Yeah, I like that. You're starting to think. I like that. You sound like a class that is whose brains are working. All right. So yeah, definitely all of those things you might want to write them down because they could be used. Beaker, filter paper, funnel, yeah. Yeah, you could use a funnel. You could even, yeah. It's just that we already had funnel already. So and that's the other thing too. So because some of the things that you might use for this one, you would use back for the other one. So you wouldn't have to write it again. So like the funnel or the glass funnel, you wouldn't have to write that back. But you probably would write beaker this time. And you'd write your filter paper. So yeah, write those down. And let me see now. Let me see filtration process. Sorry. All right, and just
Also the stirring rod.
steering rod. Yeah, write that down. Very good. That's a steering rod is. Yeah, it will come in very handy there. All right, so all right, and I'm gonna add this image beside it. Again, simple two-dimensional drawing, nothing too fancy. And it's not you're not being marked for artwork. All right, and this is the diagram for filtration. That's right beside it. Let's
Sir,
yes.
should I put the burner in my material because I chose the one with sublimation?
Yeah, man. The burner you're using the burner for sublimation.
Okay.
Yeah. But I think for this lab, you're definitely going to need a burner. You're definitely going to need one. All right. I'm going to number them though and see what you'd have there. Somebody said beaker. So the beaker would be number 6. All right. Beaker is here. Certainly your funnel would already be there. Filter paper would make it 7. As a matter of fact, in the materials you could pluralize funnel and call it funnels, since you would be using like 3 funnels. So this is a case where what if you decide to carry out this lab and you're at a school where you have a lab tech, you just give him the list so him know what to set up so that so that's the idea. That's why you want to write the materials here. All right. So 6, 7, and then of course this is a flask, so you could call this 8. This is your flask here. Your conical flask. No, it's in the Erlenmeyer flask. So Meyer flask. All right. This is how the Americans call it. Let's call it a flask. Simple call it a flask. Conical flask. All right. So you should have 8, at least 8 apparatus here. And then for finally now, we're gonna look at the third one, which is crystallization. All right, which I don't think you need much more for this one. In fact, there's one more thing you need, and you'll have everything. All right. So crystallization. All right. So what do we need for crystallization? Well, turns out we don't need that much really. Just one more thing really. Just the dish. Just want the dish based on what I'm seeing here. Just need that evaporating dish. All right. So let's go and see the material here. All right, Leandra having some connection problems. It's an interesting lab. I think this is something you guys, I really feel you can do this at home. It's just a matter of you getting the sand. Or we can get the sand. I'm thinking of if you can carry this out, what I could do is mix the powder at school and then allow you guys and pack them out in some bags and if you decide to do it, then we'll just give you one of them. Yeah, so thinking about that. All right, so I think what I like about this COVID situation is that you can get to do labs at home that students, so that you can get more hands-on experience. All right, so yeah, well, crystallization of salt here. You just need an evaporating dish. That's it. Evaporating dish. I'm trying to bring up an image on the screen though, so you guys can see what this is all about. And a phone one. All right, let me put it here. It's a bit on the large side though. Probably could crop this as well. All right, so we have it. So we're getting somewhere, guys. We're going for all of those. I believe it's 20 marks this mark outer. And see if I can. So you want to get all of these marks. I don't want anybody leaving here today not knowing how to get the full marks here. And if when I mark it, you don't get full marks, you don't have yourselves to blame. So here is it, guys. A bit on the small side. Let me just probably put it on another page in, so you can get the fullness of the diagram. But it's just one more apparatus you would add to the number, because you'd have everything else. And so this would be number 9. Yeah, you'd have everything else already. All right, any questions here, guys?
No, sir.
Sir, what is at the top?
What? Is that it up?
Yes, sir.
Evaporating dish.
Okay.
All right, diagram are materials for crystallization. All right, so there we have the basis covered. All right, if you're gonna do distillation, all right, if you're gonna do distillation, you're gonna add some more to that number. What you could do is just add distillation apparatus. So, and this is where you want to get really technical in this lab here. But this, you could add distillation apparatus as number 10, or you could add them individually, in which case you'd have just say thermometer, condenser, and this is a flask. So yeah, I'd say go the easier route. Just put distillation apparatus. Can't go wrong there. Because you're going after a short diagram anyway. All right. So cover the materials, guys.
Sir,
Yes, go ahead, Tara.
what if you don't have some of the materials
I mean,
at home? Seeing that we're going to do this one at home.
all right. Notice I said that you can choose one out of the 3 plan and design labs. that you'll be doing. So it doesn't have to be this one. If you're choosing to do this one, you can improvise, you can use other materials to substitute. All right. No, but after you write the lab, I can discuss that in another segment. All right. Because
Okay.
yeah, when you get this plan out of the way before you think about carrying it out. So a very relevant question though, but we'll talk about that afterwards. All right. So all right, guys. So we have the materials. Let's see how many marks here. We have this will be 3, including with the aim and hypothesis will be 3. Apparatus and materials, write these down. You get 3 marks for that. With the reagents here. The diagram is also there. You get 5 marks for it. I think this lab is marked more than let me just go back to the total here. 30 marks here. So cool, 30 marks. That's all right. Getting 30 marks in total. So we can get these marks here. All right, 5 marks there. Draw neatly labeled diagram to show how you set up your apparatus. You get 5 marks for that. And the diagrams are already there. So see, sir is doing most of the work for you. All right, let's look at the other marks now. All right, the method is the next thing. Method, guys. Method should be written, all right, written in future tense. You need to write your steps in future or
Sir, what are
yes.
the reagents, sir?
What are the reagents? I mean, you didn't write them off?
No, sir.
What were you doing? Look how long it was on the reagents. See the reagents them here.
Okay, sir. I got it. I got it now.
All right. All right. Write your steps in future or present. Tense, right? So it means to say you're going to write it like you're about to do it. You're going to do it in the future. Or, but the fact is you haven't done it yet. That's the issue here. Future or present tense. Any questions here, guys?
No, sir.
All right. So now, next thing now is that notice that some students when they write in the labs, you tend to put your personal pronoun in it. No, you don't. In fact, chemistry labs, you don't use personal pronouns unless you're writing a reflection. So words like I and we, you don't use those words in the method anywhere else in the lab but the reflection. And for plan and design labs, there are no reflections for this one. No. So therefore, you're gonna write in reported speech as if you're a reporter. So not to say he or she, because that those pronouns you're not going to use those, but you want to refer to the instruments by the name. So for example, first step is you're going to set up apparatus. Usually you always can score a mark here. Set up apparatus as shown in the diagram. You can't lose half of this for plan and design. Set up apparatus as shown in the diagram. So this is where I say it's easy to get plan and design marks, because you know you write this, you can't go wrong with the first method. All right. So that's it. All right. You set up apparatus as shown in the diagram. Or you could say apparatus will be set up as shown in the diagram. So you see the difference now? This setup apparatus as shown in the diagram, more like present tense, but apparatus will be set up as shown is what? Future tense, no so?
Yes, sir.
Any one of those tense are accepted. So All right. All right. So apparatus will be set up as shown in the diagram. So this is just an example of your first one. And you can't lose off of this. So whenever you're doing a future plan and design lab, your first method that's secure already. You can write this. Yeah, you can't lose off of that. And then now, this one. 1 sec. Yeah, so you can't lose off of that first method there. And remember, for P and D is a future tense or present tense. All right, let me indicate that because some persons might forget after class. So this is future and right here, so is a present. All right, so all right. The one in the bracket is the future and present tense or the other one. So all right, I hope this is clear to everyone so that we can move on. All right. So now, second method now, you're going to build on the first method. You're going to tell me now, all right, you have your apparatus, then you plan out how it when set up. But you're going to tell me now, you could do it in this order. Let's do it in the order in which it is stated in the hypothesis. The first thing was sublimation. So you're going to write the method for this. You can go back to your method that you got in your lab for sublimation. But you get that?
Yes, sir.
All right.
Yes, sir.
Then, yeah, and then now, after you write the steps, and you're going to summarize the steps. So you don't necessarily have to write back word for word everything. You can summarize it. You can skip a few steps. But then, but you can go back to that still. Doesn't matter. Go back to the lab, the sublimation, follow those, write back the method. This one, same thing for the filtration. Get that from lab number 4. So you're going to see lab number 4 method. And this one you're going to see lab. I think this was lab number 2 method. All right, so that will take care of method. Your only thing now that will be new for you is the is the crystallization and the distillation process, which you can always research that. As yeah, that and then the crystallization you can use common sense here. So that's up to you. This is the part where you have to do. All right, but that method is looking like 3 marks, I believe. Let's go back to the mark scheme fight. It looks like 3 marks. It is. All right, 3 marks because the tenths you get marked for the tenths. And you get 1 mark. You also get logical logically they mean that you don't say boy you're going to do the distillation first, then you do sublimation. No, it have to be in that order. All right, so logical flow and then tense and logical flow sequence and clear clarity and so on. So if it's not clear, if it's too wordy, too long, etc., might lose a mark there. Again, versus your clarity and yeah, I call it. Yeah, 1 mark for that. So concise and clear. All right, so 3 marks here, guys. All right. So do this on your own. Do your own method. Variables now, guys. This is where we start to do real chemistry now. So let's do a little check on the points you'll have so far, provided say you do all of these as you're supposed to. 3 marks for the method. All right. 5 marks for the diagram, that's 8. Reagents and apparatus and materials, 3 marks, so that's 11. And 3 marks for the hypothesis and aim combined. and that looks to be 14. So you have most of the marks. You almost have half of the marks actually already, just by what we're discussing here so far. This is golden. All right, let's see. All right, variables now. This is where students have some problems. What are the variables? All right, what are the variables, guys? Nobody knows? Body deciding?
Are the elements in the experiment? Don't.
The elements in the experiment. Might want to add some more to that. But variables. All right. Let's see now. All right, let me ask you this question. Interesting. Would you say we get a lot of rain? In Mandeville?
Like when? Are you saying this week or the past
Depends
month?
on the time of the year.
I like how you answer that. Depends. And you have to say this week. You see, for a moment, you have to ask when and everything. Is it those are variables? Is anything that can vary and change the outcome? So if you say we get wipe or rain, open-ended question. You say no, depends on what time of year or when. You know, you start to see what I'm saying, guys. Right? It varies. Yeah. So the results of your experiment depends on what you have to work with and how you use it. Now, these variables, the things that can vary or change the outcome of your experiment, are divided into three categories. One, you have the controlled. Two, you have the independent. And three, you have the dependent. Now, the independent variable is the one that is also called the manipulated one. This is one you control this. So you control, you adjust this one. This is the one that you so this is like the driver. Dependent is like the car. So the car can only do what the driver tells it to do. But you understand the concept there? So you
Yes, sir.
all right, so you adjusting. You are the one that is going to do the sublimation. You're going to do it your way. All right, so Tarsha is going to do it her way. Leandra is going to do it her way. Deborah is going to do it her way. Three different persons independently doing their own twist to it. That's independent. They are manipulating the technique to suit their, what they want to do. So you adjust the independent one, all right? And for the dependent one now, the object response. Object response. So that's one way you could look at it. So you adjust the independent, the object response is dependent on what you do. So that's why it's called dependent variable or responding variable. All right. So I even gave you a hint a while ago as to what those variables are. Anything that you will adjust. All right. Anything that you will adjust will be independent. Control now. Let's talk about the control one. Control one is like fixed. So this is what you're not going to change. This is one you're going to set one time and leave it throughout the experiment. All right. So the fixed variables. So for example, what would we use to create, what would we use to dissolve the salt that is used in the experiment?
Heat,
You want to use heat to dissolve the salt?
water,
Yeah, water, definitely. Water is a control variable in this experiment. Use of water. In fact, use of water. But then you have to tell me what type of water you're going to use. Is it pipe water you're going to use? Is it rainwater? So that's the thing you will answer. Fix that. My recommendation to you is to use distilled water. So I'm gonna put distilled water here, and then now, in fact, there's probably just one time you should use distilled water is when you're trying to dissolve the salt and when you're going to do the filtration. So which is in the same capacity anyway. So distilled water is a control variable, but then we want to probably be specific here with the volume now. We want to keep that volume of water constant. So if we have a buckle in the experiment with water on the side, then that will be controlled, right? So you're going to use a certain volume of it. All right, that is control, that's fixed. So it's not like you're going to go back and change the volume of the water use. You should fix that. But there are some other things that you're going to control as well. Definitely going to control. This you want to keep control. Now, will it be? Let's see, there's some other stuff. What about the powder? Let's see if we can look at that powder. In fact, let me see if I can get an image up with that powder. All right. All right, so. All right, I don't want you to understand here. Is it that we're going to use? Is it that we're going to use the same amount of powder to do this experiment? Let's see. Or is it that we're going to keep dipping? Let us say we'll get the powder in a bag then. You'll get a sample of the powder. Will you use all of it or some of it? Or would you keep adding powder to the experiment? Or you going to just use a fixed amount right through? Things like that. You see, you need to understand what's happening. Let's go back to these steps. All right, let's say we're doing sublimation first. All right, so you're going to get the powder and all of it really, because the idea here is that you want to separate the specific powder. So therefore, you don't want to fix that amount, guys. You don't want to put, so like, for example, you start sublime here, and then you go back, take up some more powder, put in here. No, you want to put it in there one time, guys. Hope everybody's understand what I'm saying. All right.
Yes, sir.
So you put the powder in there one time. All right. Make it sublime. So when you sublime it now, what it means now is that the ammonium chloride will be separated. All right. So that gone. Whatever leave back now, going to go into the filtration process. All right. Then now the residue now would be the sun. Then whatever leave back now. So in other words, you're not going to add any more powder whatsoever. You just one time you add the powder, guys. We'll be seeing what's happening. All right. So the one fixed powder, amount of powder is going to be used. Therefore, it's a control variable. So you could say amount of powder used. Yeah, there you go.
So would another one be the amount of salt dissolved?
Well, no, that wouldn't be a fixed one. That will come under the amount of powder because the powder contains the salt. Forget about salt and them something there. Those that you're telling me, that you asked me about, that will be a responding variable. Because at this stage, you're not supposed to know the salt in there. Or let's say you know, but then you're not gonna have the evidence of salt being in there. Right? The control variable, guys, is like before you start the experiment, or what you plan to do. So you basically, I tell you, say the method supposed to tell me, say you're going to put a fixed amount of powder, right, in an evaporating dish. Right? That I mean actually giving away the second method there. You get the fixed amount of white powder and put it in this case, China dish. Yeah, and that's it. That's fixed. You could even go as far as to tell me how many grams you plan to use. That would be a fixed amount. Everybody here understand what I'm saying?
Yes, sir.
Yes, sir.
All
Yes,
right.
sir.
Yeah.
Yes, sir.
All right. So the mass is fixed. So let me just make a note of that here. All right. Mass. So that is controlled. So that now go change. And we get 1 mark for that. In fact, if you just put the amount of powder and the mass of the powder used, that's 1 mark for that part. All right. So now let's go on to the part now where you have control over, where you are adjusting or you are manipulating this now. All right. So now that you know what you're not going in trouble, let's go to what you go in trouble. You're going to trouble the process. You're going to do the sublimation. So use of sublimation. Let's put, yeah, in fact, let me just put it as it is. Sublimation is that you going to do that. You're also going to do the filtration. And you're also going to do the crystallization or distillation. So because you are controlling it, it's manipulated. No, after you do all of these things, after you do the sublimation, how would the powder respond? What is obtained when sublimation takes place? What is the name of the thing that is formed? All right, so that would be your responding variable. So if you didn't know this word before, I'm gonna give it to you now. It is a sublimate. So sublimation supposed to give you a sublimate. This is responding to your sublimation. All right, let's go back to the diagram and show you what's happening. So guys, this is it. The entire setup here is sublimation. But what is formed here? The ammonium chloride sublimate. So this is supposed to deposit deposited on the funnel. Yeah. It's gonna be deposited on the funnel. That's a sublimate. So this is the responding variable. I hope everybody is seeing this. All right. So the filtration now, what is formed from filtration? What do we get after filtration has taken place? Anybody?
A
Sir,
filtrate.
filtrate.
Thank you very much. Filtrate. And there's something else. 2 things you get from filtration. One is a filtrate. What's the other? You forget the lab already? Let's go back to the. All right. So you get the filtrate. See it here in the diagram. Filtrate. What is this here? Filtered solid is what? What we call that?
Residue.
The residue.
All right. So residue are 190. So when you do filtration, you always get a filtrate and a residue. Everybody see that?
Yes, sir.
All right. So sublimate, filtrate, residue, and of course, the result of the crystallization. Yeah, the result of the crystallization. What would the result be?
Crystals.
Yeah, that's it.
Mm.
Mm-hmm. That's it, you know. We finish this. Variables and finish. Any questions here?
No, sir.
No,
All right.
sir.
So in addition to the 14 marks that would have counted so far, this is 3 more. This will carry to 17. So then where the rest of marks, oh, because you're going to get 10 marks for that. Okay. All right. So yeah, we finish here. And it's 17 marks. That's more than half of the marks. And then we're saying no data to be collected here. All right. So this is like given to you. So you won't get any marks there. It's like you can write this off. I usually tell students to put it in a table though, make it neat. So I could say I convert expected, no, convert data to be collected in a blank table. So you're going to draw a table and tell me what would be the heading of the table, etc. So convert data to be collected. What is the data to be collected is what you plan to collect throughout the experiment into a suitable table. No results must be in there, guys. I don't want to see any results or any conclusion for this lab because you have not carried it out. You're only planning to carry it out. All right. Hope I'm making myself clear there. So,
Yes, sir.
all right, convert data to be collected into a suitable table. So, an example of that would be like you have your columns here at the head, and then you just write. Let's see what would have up here. Observation. You'd just modify this. So you could say mass of powder, and then that would be in grams, and then of course the observation. Because the thing about this, this is where you can actually, and this is where the lab get interesting. You see, because you're taking mass now, would have to go add that to the apparatus to add beam balance to it, I remember say we measure the mass. We have to go add that to it. If you go measure the mass of the powder, we have to put beam balance here. So hope you understand. Say this lab now, I want to see your lab. All right, beam balance to measure the mass. Add that there to the 10 that you would have so far. This will make 11. Beam balance will be there. And I'm seeing something that will come out of this lab. After you do the sublimation, now I'm going to add something to the method that would help you get some marks. All right, the second step now would be to, all right, measure mass of white powder, and record results. All right, what I'm also seeing here too is that if you do that, you can record the mass of all right, a funnel, mass of sublimate and funnel rather, sorry. All right, measure and record. All right, now probably before this you don't measure mass of funnel as well first. because this would be 2, this would be 3, and this would be 4. All right, because yeah, the mass of the funnel before you do it, you want to know how much that weighs. So you want to know, say, when time you do the sublimation and the ammonium chloride I go sublime on the surface of the funnel, right? Then this is it. You want to take off this part and you going to measure the mass of it. So it should be more than the funnel when this sublime on it. You're going to subtract that mass now from the mass of what you put in the dish. So that's why a table is important for this, guys. So you guys will have to sit down and work that out together. All right. You don't need me for this. You just need each other, or you need your brain. You know, you have to do some work here. All right. Mass of powder. And you see, mass of powder, and you have your mass of sublimate. You know, all of these things here, you have to record. And then of course the observation or the time when you use to heat it. Time is important here, because how you going to know when to take off the mixture off of the fire, off of the burner? That's the issue here. All right, so time for heating. So so time, intervals of time. Yeah, you have to get creative here, guys. So this is just an example of a table, but I can tell you that you're going to have a table with 2 rows and about 68 columns. All right, so 2 rows, and then of course you're going to give me a title for the table as well. So we'll pick up a few extra marks for that one. All right, so yeah, you need a table. Any questions here, guys?
No, sir.
All right.
Sir,
So
appearance would be one of the headings too.
all right, good question. Will appearance be one of the headings? You don't have to be, you know. It doesn't have to be. I put the 3 compulsory ones that it should be in there. Let me see something. Is there room for the appearance? You know, you don't need it. This lab can be solved based on measurements alone. When I was planning this lab, I was thinking that you would just use your eyes and say, oh, it's done. But then you know your limitations of your eyes already. So, but doing it with you guys now, I realized that we could actually use the measurements to see if we get a pure mixture. So yeah, observations will come in the last part though, Casey, because look at it now. When you do the yeah, because the final product is the salt. So you went right, say, like in the end now, when you have the salt crystals formed, you can write the description of the appearance. So yeah, so this is crucial. Let's put a tick there. Evaporate, distillate, appearance of the residue was done. Yeah, this last one will be in there. Yeah, cause you want to know if it's pure. If it's pure, then you would have been successful. But certainly what I tick here, look, that must be in there. Them 3 they compulsory. But think about it and see what other things could be in there. You know, you take it from there. All right. I'm giving you up to 5 marks for this. All right, it'll be 5 marks. All right. So guys, let me say, if you do your table and so now, you get extra 5 marks here. So I'm gonna start that out. This part now, up to 10 marks you get here. and it's going to be answering 5 questions. What is expected to happen when the mixture is heated? All right. No. All right, so it's going to be heated in sublimation. All right. So definitely sublimation is what you expect. Sublimation, sublimate form. So this is just answering the question. And that's 2 marks there. So that's all they're going to do here. Answer the questions to get the remaining marks here. All right. Well, we say sublimate will be formed. You get 1 mark for that. But you're going to also tell me now what it going to look like, what it's expected to look like. All right. So you know, go have to research and tell me now what is ammonium chloride expected to be. Easy 1 3 that. Just go on Google and type that in, and then you write the answer there for the extra mark. So that's all right. So every line of answer you give me, provided that is correct, it's a mark. That adds up to 10 when you do all these 5. Any questions here, guys?
Sir,
Yes.
expected results that I have, it's
Mhm.
different.
It's different.
Because you have questions on yours.
Right.
This one says ammonium chloride is like, oh, is it telling you what happened?
Mm-hmm.
Okay.
Yeah, man. Tell you what you expect to happen. So you would write something like, if you're gonna combine this in a paragraph, it should read something like, it is expected that ammonium chloride will sublime upon heating. Full stop. Right?
Okay.
Yes. The ammonium chloride, the ammonium chloride is expected to be a white powdery solid, etc. All right. Just continue along that line, but that's what you're going to talk me through in the expected results, what you expect to happen based on your knowledge. All right. And that's it. All right. 10 marks there. And we're closing in on the 30 marks here, because with those 10 marks and the 17 that I said you would have from before, that carry to 27. And then of course I added the 5 bonus marks for the table. So all right. And we're closing in on this lab there. It's actually the precautions now and the source of error and the limitations here. All right, precaution. You guys should know what precautions are. All right. Anybody can tell me what a precaution is?
Prevent how to prevent something errors from happening.
All right, I'll accept that. Yeah, prevention of errors here. So what precautions are going to be taken for this lab?
Sir, when you said we should not put, when we already have the powder, we don't have to add the powder if you start the process already.
Okay, all right, let's stick off in there. All right, so all right, hold on a sec. No, that's I wouldn't call that a precaution though, Leandra. That's a variable. That's a fixed variable. All right.
Okay.
So, yeah. So no, that's different. So precaution now is anything you can take into well, prevent not just errors though, but harm to yourself. So you can't lose off writing protective clothing. Goggles, definitely with ammonium chloride, you don't want that to get in your eye. So we can say use of goggles there. All right. But there's one even more simple than that though. If you go back to this diagram, look at that. Look at what number 5 is. You see that?
Yes, sir.
Yeah, cotton plug. So that's a precaution, you know. Place a cotton plug on the inverted funnel to prevent the escape of ammonium chloride. All right. Use of goggles. All right. What else we see in here? Any precaution that you have for sublimation, write it back. you go back to your lab. It's in lab 2. So I'd say here, C lab 2 method, you're going to also see precautions as well. Any precautions you have there? All right, the method and precautions, look at those and get free marks for your lab. All right, these marks,
Sir,
yes.
question. If we're only planning to carry out the lab, we still need to write precautions and all of that?
Yes.
Mm.
Because you're planning to carry it out. It's like you want to tell the examiner that you know what you're going to face before. You understand?
Okay.
So, yeah. So before you do the lab, you're going to carry your goggles. So that's why you need precaution. Pre mean before. So you write that down. All right. So yeah, definitely need to write that. All right, so you get a 1 mark for for the precaution, and 1 mark for the source of error. Again, guys, you can go back to your previous labs and filtration and sublimation to do this one. All right, and of course limitations. No, you can limitations. Something that we can discuss there, because in fact I might just discuss it. When you decide to carry it out. So don't trouble limitations. Just do up to source of error. I'll take care of limitations some other time. But the limitations for this one would be the fact that it might not be possible to fully separate the 3 substances due to maybe the type of equipment that you have and so on. There's so many limitations. Maybe some of the sand could dissolve in the water as well. Some parts of the sand may be soluble in water. So therefore, it wouldn't be as accurate as you would hope. Depends. The type of sand is a crucial part here. Things like that. And also in the sublimation, and all of the ammonium chloride could or would sublime. So yeah, those are limitations. But I don't want you to trouble that. I just want you to be aware of it. And I'll take this on in another class. That's after you handed in this lab and we can go through it. All right. So this is it, guys. Plan and design lab. That's it. 30 plus 5 marks here for the table. You carry the number to 35. All right. So any questions here, guys?
No, sir.
All right. Well, that's it, guys. I think we have done quite a bit here. So you must go now and finish this lab. I've guided it to most of the marks that you can get. So just follow through on it. Just be diligent and follow through. Don't put it off. Best time to do it is now when it's fresh. You can meet and discuss, ask questions in the group. All those things can be done. All right. And as a matter of fact, while we are on this, we can just save this document. All right. Let me